Okay, these are the MAT 1140 notes. This is chapter 17.3. This is circles. I am definitely not going to read definitions for you up top here, but they are all right there. We are going to focus here on using the formulas, specifically the formula for circumference and area, and we'll fill in some of these terms as we go. Example 1 wants the circumference of the circle with the following dimensions. So circumference. In A, you are given the diameter. We are using the formula for circumference that uses diameter. Pi times, here it tells us the diameter is 8. So 8 pi. When we plug that into the calculator, we get 25.13. It says round to the nearest tenth, so 25.1 centimeters. For B, notice that we are given the radius this time instead of the diameter, so we are using this formula for circumference. Circumference equals 2 times pi times r. Remember the relationship between the radius and the diameter. Radius is half the diameter. Diameter is 2 times the radius. So here we have 6 times pi. When we plug that into the calculator, we get 18.849, again rounded to the tenths, 18.8. We need to include that label. Our radius was in inches, so our circumference is in inches. Example 2, we are finding the area. Notice that we only have one formula for area. Area equals pi r squared. Pi is that relationship that we find in circles. It's the relationship between the circumference and the diameter. So here we've got pi times our radius squared, 16 squared. So 16 times pi is what we are entering into the calculator. And we get 804.247. Again, we are rounding to the tenths, 804.2. Because it is an area, because we squared the yards in the radius, our answer is in terms of square yards. So 804.2 square yards. In B, we're given the diameter. Problem is the formula for area does not use diameter, it uses radius. So we need to start by finding the radius, and we're going to take our diameter and cut it in half. And we get a radius of 2.75. That is what is going into our area formula. So take a minute, square 2.75, and then multiply that by pi. We get 23.758 again. 23.75 to one place is 23.8. And it is an area, so inches squared. Last one has us using complex figures again. So here, we are trying to find the blue shaded area, not the green in the middle, the blue shaded. Okay. My large circle has a diameter of 1.4 meters. My radius is going to be half of that. My small circle inside has a diameter of 1.1 meters, so my radius is half of that, 0.55 meters. If I want this blue shaded area, I cannot just subtract radii. I have to find the area of the large circle, subtract off the area of the small circle. The area of my large circle is 1.539, 1.54. My final answer's got to go to 1/10, to the 10th place. So I'm going to take these answers to the hundredths. Zero point, what, 95033. When I subtract those, I get 0.589, 0.59, 0.6 square meters. B, notice that we've got a semicircle coming out of a rectangle. So the area of my rectangle is length times width. Notice here I have half of a circle. My diameter is 1.5 feet. So my radius is half of that, 0.75. So my total area is going to be the the area of that rectangle minus 1/2 the area of the circle. Two times 1.5 is 3. The area of my semicircle is 0.8835. Since I am rounding to 1/10, I'm going to carry this out to the hundredths place. When I subtract those, I get 2.1164 to the 10th place, 2.1. And what's our label here? Feet squared. Square feet.